Hey guys, welcome to Unit 3. You've done a really great job so far this year, and I'm so proud of all of you for making it this far. This unit is all about working with language and translating English to algebra and solving a variety of different kinds of word problems. So this unit is really about word problems. So in Lesson 1, let's take a look at the aim. I can create algebraic expressions and equations by translating English phrases into variables and numbers. There'll be many instances when we have to translate phrases from English into mathematical expressions. This is a skill that takes a lot of practice and time to get good at. In this lesson, we'll begin to build this fluency. Let's take a look at exercise 1. It's important to be able to recognize addition and subtraction in phrases. So in this exercise, we're really going to focus on addition and subtraction. First, let's begin with some numerical work and then transition to expresses that contains variables. So let's take a look at A. A says, write a calculation and a result that represents a number that is 5 greater than 3. So when I see greater than, that means to add, right? So if it's number 5 greater than 3, that number's 8. And I can write that as 5 plus 3. Okay? 5 plus 3. Greater than means to add. B. Write a calculation and a result that represents a number that is 2 less than 9. Now this one's tricky. Less than means to subtract. But it also means to switch the 2 and the 9. Because take a look, if I want something that's 2 less than 9, do I want 9 minus 2 or do I want 2 minus 9? If it's 2 less than 9, then it's got to be this first one right here. 2 less than 9 is the number 7. Correct? If I have 2 less than 9, 2 minus 9 is negative 7. We want the positive 7. So remember, when you use the phrase less than, you subtract and reverse the numbers. So that's a trick. Letter C. Write a calculation and a result that represents the sum of negative 3 and 8. Sum means to add. So I'm going to have negative 3 plus 8, and you can use your calculators and you will get a positive 5. Okay? D. Write a calculation and a result that represents the difference of 20 and 12. Well, difference means to subtract, and in this case we do it in the same order. So 20 minus 12 would give me 8. Okay, so notice that we're just the phrases I'm underlining: greater than, less than, sum, difference, clue you into what kind of operation you need. So we're translating like we would a foreign language. Letter E. If x represents a number, so now we're working with this letter x. If x represents a number, write an expression that represents a number 10 greater than x. Well, greater than means to add. So I'm going to have 10 plus x. And I'm done. I've written an expression that's 10 greater than x. Letter F. If n represents a number, write an expression that represents a number that's 5 less than n. Well, remember that less than means to subtract and reverse, so I'm going to have n minus 5. Letter G. If y represents a number, I'm not quite sure why. Hold on just one second, sorry. If y represents a number, write an expression that represents the sum of y and a number 1 greater than y. So I'm looking at this phrase sum. So sum means to do what? It means to add, right? But add what? The sum of y and. This letter and signifies where you're going to put the plus sign. So I have y, so there's my y, and there's my plus, so y plus, and I'm going to split it up, and a number 1 greater than y. So that's 1 greater than y. I have to add, so I get 1 plus y. Okay. Letter H. I'm not sure what this is in the middle here, and I don't know how to get rid of it, so we're just going to ignore that stuff in the middle. H. If n represents a number, write an expression that represents the difference. Okay, so I'm going to have to subtract the difference between a number 1 larger than n, and that's where it tells me to split. that's my split where I'm up to my subtraction sign. So I have a number 1 larger than n, so that's n plus 1, right? 1 larger than n. And I'm going to put that in parentheses and put my subtraction sign. And 1 smaller than n. Well, smaller means to subtract, so n minus 1. This is really tricky to try and think about. Notice how I've underlined difference to let me know I subtract. And I've split up with my underlining. In fact, let me pick a different color because that might help. Okay, so I'm going to split up my coloring. So this part right here, between a number 1 larger than n, is that right here, right? That's that phrase. The blue part, and, that's where I have my subtraction right here. So I have this subtraction symbol right here, and that's where I get the subtraction difference. And then the second part comes from this right here. 1 smaller than n is right here. This was a tough one, and there's where I get the difference. Okay? We also need to be able to translate multiplication and division. So that first exercise was just addition and subtraction. Well, now let's take a look at multiplication and division. Multiplication is typically easier to spot and translate than addition and subtraction. So let's practice. Exercise 2, letter A. Write an expression for a number that is 5 times greater than 2. 5 times, that means multiplication. So I want 5 times 2. So 5 times 2 will give me 10. That's a number 5 times greater than 2. Letter B. Now if n represents a number, write an expression for a number that is twice n. Twice means 2 times. So I have 2n. Letter C. Write an expression for the quotient or ratio of 12 and 3. Quotient or ratio means division. So if 12 and 3, I'm going to make 12 go on top and 3 go on bottom. Letter D. If x represents a number, write an expression for the ratio of x to 5. Ratio again means division. And if it's x to 5, x on top, 5 on the bottom. Okay, starting off simple. Exercise 3. Now we want to be able to put operations together and create complex expressions. These can be tricky. It's always important to read them carefully, think about your order of operations, and check with a real number. So let's take a look at A, and I'm going to use a lot of different colors here to try and translate this and show you how this works. So let's take a look at A. If x represents a number, write an expression for a number that's 3 more than twice the value of x. So the first thing I see is this 3 more than. Well, more than means to add, so I'm going to have 3 plus. The next part says twice the value of x, so twice x. So my expression is 3 plus 2x. I'm breaking it up and translating each part. Okay, let's take a look at letter B. If n represents a number, write an expression for 2 less than. So that's the first part. So when I see 2 less than, I know it means to subtract, but I also know that that subtract needs to be reversed. So I have to put the minus 2 at the end. 2 less than. Then I have this 1/4 of n. Of is a key word that you mean multiplication. So I want 1/4 times n minus 2. Okay? That's 2 less than 1/4 of n. Okay? And by the way, feel free during this part of the lesson to go ahead and try some of these on your own. You can always pause and work ahead and then see if you're correct. A lot of you are struggling on your mastery, and part of that is that you're just copying down what I'm writing here, and you need to start taking the initiative to try these on your own and work through them by yourself to figure out where you're making mistakes. So please feel free to pause and always try on your own. Alright, letter C. If S represents Sally's age and her father is 4 years less than 5 times her age, then write an expression for her father's age in terms of the variable S. Now that sounds like a nightmare. So let's break it up piece by piece. The first piece, I'm going to say that S is Sally's age. And this problem wants me to write it in terms of s. This in terms means use that variable. So it wants me to use the variable s. So I'm going to use the variable s, and I'm going to take a look at the next part. Her father is 4 years less, so 4 years less, that tells me I have to have a minus 4. And the second part says that than 5 times her age. Well, her age is represented by s, and I want 5 times, so it's 5s minus 4. That doesn't really look like a 5, so let me just make that a little nicer. 5s minus 4. Okay? That's a tricky one. Letter D. If x represents a number, write an expression for 3 times. So I'm going to have 3 times something. The sum of x and 10. Now, I know the sum of x and 10 is x plus 10. But this is saying it's 3 times this entire sum. This entire sum. So I need to use parentheses and have 3 times x plus 10. Because I'm going to have to distribute that 3. So always use parentheses when you have something like the sum of something. Right? Use parentheses. Use those grouping symbols. Letter E. If n represents a number, then write an expression for 7 less than, so I'm going to have a minus 7. Then what's the next part say? 4 times, okay, so I'm going to have 4 times something, the difference of n and 5. Okay, the difference of n and 5 means I have to subtract, so difference means subtract. So in parentheses here, I'm going to have n minus 5. So 4 times n minus 5 minus 7. So do you see how I'm breaking apart the sentence and translating each bit at a time? Okay. Letter F. If x represents a number, then write an expression for the ratio, so there's a clue I need division, so I'm going to make a division line right here, of 3 less than x, hold on, 3 less than x, that's my first part. This 2, that phrase 2, clues me in on where I'm splitting. So 3 less than x, so that's x minus 3. 2 more than x. 2 more than x represents addition. So I'm going to have 2 plus x. So x minus 3 over 2 plus x is my expression. Okay? Letter G. If x represents a number, then write an expression for the sum of twice x with twice a number 1 larger than x. When you read it out loud all like that all at once, it's really scary, so we're going to break it up again. I'm going to stop where I see write an expression for the sum of, okay, that's my first clue, I'm going to have addition, twice x with, that with is where I'm going to have my plus sign. So what goes in front of the plus sign? This part right here. Twice x. Twice x is written as 2x. And what comes after that word with? After the word with comes twice a number 1 larger than x. So a number 1 larger than x would be x plus 1, but I want twice that. So I have this phrase. 2x plus 2 times x plus 1. Okay? That one was a little trickier. H. If n represents a number, then write an expression for the quotient. What's quotient mean again? That means division. So write an expression for the quotient of twice n with is that big clue, that's where I'm splitting it. When I see with or and, that's my clue to split. So I have twice n on top, because it's a division, with 3 less than n. Well, 3 less than n, right here, 3 less than n is n minus 3. So 2n over n minus 3. Now I'm using the different colors because I'm hoping that as you go through here you can see that the colors represents where I'm translating the phrases. So where you see the underline, that should match where your math is. Last two, letter I. If y represents a number, write an expression for 3/4 of a difference of y and 8. So 3/4 of right here, what does of represent? Of represents multiplication. So 3/4 of is like saying this, 3/4 times. Then it says the difference of y and 8. So difference, and I'm going to put in parentheses because I have these two things, y minus 8. So 3/4 of y minus 8, the difference of y and 8. And finally, the last one, if x represents a number, then write an expression for 1/2, so 1/2, the sum of x and 4. 1/2, the sum of x and 4. So the sum of x and 4 gets its own color because it's a new thing. Remember what I said about parentheses? It's 1/2 the sum of x plus 4. Okay? Alright. Remember, you can pause at any time, go back, re-listen. And remember, you can always ask me questions online, an email, on the phone, on the help forums if you're stuck or confused. Okay? Finally, exercise 4. Neat patterns can occur repeatedly when you play around with numbers. A fairly easy one occurs when you add a number to one less and one more than the number. Do this for a few numbers x, record the results. Then prove a general pattern by writing an expression for the sum of a number with a number one less and a number one more than it. Okay, so let's take this one step at a time. The first part wants you to test with a regular number. Okay, so I'm gonna pick some easy numbers. I'm gonna make them up. So let's say I pick 1, 2, 3, and 4 for my x's. Okay, now I want to take a look at the actual pattern here. So I'm gonna highlight this part. When you add a number to one less and one more than the number. So if I start with the number 1, what am I going to do? Add a number to one less and one more than the number. So I have the number 1, and I'm going to add one less than the number. What's one less than the number 1? 0. What's one more? So that's the one less. Okay. In fact, let me. I'm going to use colors to help with this because I think this might be a little confusing. Okay. Sorry. So what's one less than the number 1? 0. What's one more than the number 1? 2. So those are the three things I'm adding together. One less than the number 1 and one more than the number 1. So what's 0 plus 1 plus 2? That would be 3. So my sum would be 3. Does that make sense? Number 2. Let's try the number 2. So I have the number 2. What's one less than the number 2? 1. And what's one more than the number 2? 3. So I'm basically adding 1 plus 2 plus 3 to give me a 6. Let's test the number 3. If I start with the number 3, what's one less than 3? 2. What's one more than 3? 4. And 2 plus 3 plus 4 is 9. Now, I hope you're starting to see a pattern here. If I have 4, 1 less than 4 is 3, and 1 more than 4 is 5. So 3 plus 4 plus 5 gives me a 12. What is the pattern that we're seeing here every time? Now, yes, they are each going up by 3 every time, but let's pretend that I'm looking for the pattern on how do we get from the number 1 to the number 3. How do we turn a 2 into a 6? How are we turning a 3 into a 9? How are we turning a 4 into a 12? What is the math that's happening to that? So let's turn that into an algebraic expression. So if I take this, my original number, my original number is x, correct? Oh wait, let's make that black to match the color. I start with x. And what did I do in number 1? What did I do to get this 0? I did 1 less than x, correct? Well, how do I write 1 less than x? That would be x minus 1. And how did I get the red number 2? What did I do? That was 1 more than x, so I had x plus 1. And then I just added those two things together, correct? Now we can simplify. Let's combine like terms. I have an x, and an x. How many x's is that? That's 3 x's. I'm going to cross them out because I'm done with them. And then what's negative 1 plus 1? Oh. Negative 1 plus 1 is 0. So that just leaves me with 3x. So what is the pattern here? What's the pattern? How do I go from 1 to 3? The pattern is that I'm multiplying by 3. So let's say I pick a number like, I could pick the number 20. What do you think the number here would be? If I were to find the sum, it would be the number 60. I times it by 3. But the number 100, what do you think it would be? 300. And we can test this. I can say, okay, let's do 20. One number less than would be 19, and one number greater would be 21. What's 19 plus 20 plus 21? It's 60, so it works. So we need to, part of our work in algebra is to look for these kinds of patterns. And it's kind of weird that we're just adding up 3 numbers in a row, and we're finding that's the same thing as multiplying by 3, which is actually kind of cool. Okay, so that's lesson 1 for Unit 3. Good luck on your mastery, and I will see you in class.